Hello everyone, this is Surya from the Document360 team and I'm the co-organizer of today's webinar. Thank you all for joining us today. We truly appreciate you taking the time out of your busy schedules to be here. So we got an exciting session ahead and I'm sure you're ready to get started. It's time to dive into today's session. We are honored to have Gopalkrishna Tharoor with us, who is the project manager at Pride Global. So a little background on Gopal. So he's an industry expert with close to 34 years of experience in working across multiple phases of documentations, right from requirement phase to the release phase. So he has covered domains like BFS, flight test computing system for Boeing 787 Dreamliner, quality assurance, content and design service, and much more. And currently, he's a project manager who's involved in writing RFPs. So by the end of the session, you'll be able to discover, how through testing of API designs, kind of like the essential for enhancing the API performance and how this approach will enhance user experience and foster trust among the users. So as always, we want this session to be as interactive as possible. So right after Gopal's presentation, we'll be opening the floor for Q&A, and I encourage you to drop your questions in the Q&A section of your dashboard as we go along. So, this could be your chance to get expert advice tailored to your needs straight away from Gopal. So without further ado, Gopal, the stage is all yours.
Good morning to everybody on the call, and warm good evening to my friends here in India and Asia. So, without further ado, thank you, Surya, for the introduction. I took up this session because everybody was talking about API documentation, but there is a stage prior to API documentation which talks on what should be focusing on, how well the design should be architected, and what should be tested, just like you test the other components of your SDLC. Now, this is essential for us to understand these components, simply because we are going to see a big exponential growth, as you will see in the coming slides. Now, let's take a classic example. Your typical day could be, you would have entered Google in one of the browser windows, gone and searched for something. You've come a long way from providing your search string within quotes, adding a plus sign separator in between, and picking up the next quote. But by the time you've completed today, the search itself is narrowing it down, and it's become an intelligible search where it's trying to tell you what are you looking for, and narrowing it down to the top 3 or 4 sites that you want to click on. Such is the process of way Google has gone. Similar is the case with other APIs, as you are about to see of this. Right here on the left hand side, your typical day is like this. The monsoon season has apparently started, so you go to some weather app and check how bad is your day going to be. During the day, you would probably have some plans for the year end, so you're trying to do a booking, plan a hotel reservation, at the same time open up your app for doing your flight booking, as well as reserving your hotel accommodation. And simultaneously, if you are a vivid vlogger or a blogger on a daily basis, your thoughts for the day are getting blogged. These are typical APIs that function in your daily life. And at the same time, while you're doing all this, there is in some process where some reservation has led to you making a payment, and there is an OTP coming to your mobile to verify that you are the actual person for whom the reservation has to be made and amount debited to the user. On the right hand side, this is how the global application programming interface market is going to explode on our face. By 2027, you're looking at an USD 13.7 billion worth of market, which is what the stats say. And this is done by one of the primary research and markets organization, which every year comes up with some kind of top 10 or top 5 in terms of whatever trends that you want to see. These are the forerunners who come and publish this kind of information. So in 5 years, you are seeing at least a 3.5 times the growth of the API industry that is going to happen, and the amount of money that is going to be brought in as revenue is will be focused on API. So I am not discounting the use of API documentation, but here I am saying we need to be ready to work with API documentation, which may be the way forward. And with a little bit of artificial intelligence coming into play, you may also have what you call, not that you're going to get overridden or you're going to become redundant. We have come a long way, that much assurance I can give you. But you will find that little bit of, uh, I should say, intelligence is also going to get built into the system courtesy AI. I'll stop there. I will not kind of go beyond the scope of this session, nor do I focus on my session is about AI. Now, what are the requisites in a typical design? As somebody who works in an organization, these are the typical gadgets that you may be focused on. So, as in any SDLC process, your core API should also be focusing on some non-functional requirements. Here, like I was saying, the time and the device has shrunk vastly from what it used to be earlier. So the non-functional requirements that I require from a computer has shrunk drastically in terms of what I should be seeing on my smart device, or even now a wearable ID. So what it really matters is that from an API design perspective, you should have very clear what I call endpoint structures. If I start at one location by providing HTTPS and saying something, the endpoint to which I should get to should be well defined. For that, my resources should be aptly named, and those resource names should not vary from entity to entity. Right now, what I call, let us say, a payment should also be recognized by the second API as payment. But what I say in payment in one of the labels, where I'm saying payment for reservation, there it should say payment from user, right? So that subtle distinction between the naming conventions should not be very extensive, but it should be very, very marginal, is what I should say. And at the same time, for the operations that you are going to use, please understand any API works on something called your compile, read, and CRUD operations. Right now, for the CRUD operations to exist, which is your standard commands like get, put, post, replace, delete. For all of these functions, you should have effective HTTP methods, because every API transaction is going to work in the browser window. So that should be well defined. After that, there comes this component called, you will have something called a small piece of code that is you have written, which will work in a nested mode, that for this many details you have to go in, this operation should particularly work for you. And at the same time, as your API is willing to accept more and more users and willing to accept more and more transactions, it should be effectively be able to scale up. So that's exactly how your design should focus on. It should focus on four aspects. One is from where one point to the from one address, where should the endpoint end, and that endpoint will have a classic result. It will be either true state or a false state, based on which, if it is true, it will do something. If it is false and not available, it will result in an error message. What is the most classic message that one has encountered ever since the use of Google has come in? If something is not locatable, error 404, website not found, right? We see that quite often in our lives. Now, that is now getting more and more user friendly and becoming more and more uh, adaptable to the usage of the API. And so these are effective design steps or statements that we will write in the background to make sure that it is user friendly. Just like UX is being made user friendly from a documentation perspective, even our API are being designed to showcase that they are equally user friendly and as crisp as possible. Now, one thing that I have noticed here, while we work on these design requisites, there are something called the design principles. Is it showcasing the basic principles of the API design? Right? Now, I have a mnemonic to remember this. I call this CS cube CB. Now, what do I mean by CS cube CB? Is just the first letters of each of these 6 principles to remember it easily. So, I go through consistency, simplicity, security, scalability, collaboration, and the business benefits. So, if I remember it as CS cube CB, I am able to remember the basic principles of ABI design. So that's what I said. You need to follow the CRUD principles. That is, you have to have a create, read, update, and delete functions. All this are HTTP methods and actions which you have to put in place, and these have to be consistent. It cannot be what you call varying across API to API. These are standard API operations, or what you know as CRUD: create, read, update, and delete. Now, next thing is you must look at how the API design is. It should be as simple as possible. Is it going to work well on XML, or should I use JSON? Or do I have some proprietary format, as some of the products that are available in the market which says that we are using open API? Now, then you have to look at the method structures. Is it something that is allowing you to work on certain sequence, or is it just that the broad set of data is, you provide the information and you're looking for a specific request? You should also look at what is the data model that you are going to use, right? And finally, you should focus on the authentication, and you should abide by, for any standard API design, there is something called, we will abide to the usage policies as defined by the system. You undertake a system terms and conditions that are met, you say I agree. So that means you abide by the usage policies and don't try to manipulate the system or come up with our own. That is as far as the simplicity is concerned. When it comes to security, wherever necessary, our lives have become ruined by this component called hacking and phishing. So we have to be extremely careful and be very careful to use HTTPS. So you have a secure browser window on which these operations are run. Make sure that your URLs are not exposed, or to prevent any hacker from getting in through loose ends. Your endpoints have to be so secure that in the second click or the third click, the user is able to get to where they want. Frequently, you should also have a feature where in the background, your server logs as well as your sensitive information that you use should be well protected. Similarly, the headers that you provide in terms of the naming convention, if they are taking care of any sensitive information, be very careful that they are sent in an encrypted mode. And at the receiving end, these packets are decrypted effectively. All this will ensure that you take care of the security aspect quite well. Now, if you look at scalability, please understand, earlier when Netflix launched, Netflix looked at an option of where I could have 5 people from the same house and I create 5 user IDs. Over a period of time, Netflix decided to explode like mad. Now, what does the API work? On a monthly basis, they are checking and seeing if I am the user designated to watch their programs. And today, everybody has got an user ID. So, if my wife wants to watch Netflix, it has to be her own account and she has to pay separately. So, that way, from a small service, what they have done, they have become almost billion users, right? In the US, there is a subscriber base for a very small activity called Sling TV, but now it has grown so bad, in the sense that people all over the place, besides whatever Netflix or OTT can offer, have adopted to Sling TV in a big way, right? So if you look at it as a single purpose solving problem API or a subscriber base, then you have to remain focused with your APIs and build it so securely that people are able to enjoy, and that's how the platform will grow. And finally, and most importantly, to be in the marketplace, you have to collaborate with other APIs very effectively. You can't say that I will not interact with Razorpay or Paytm, or these are some components that are coming to mind. You can just not be focused that we will accept only Google Pay payment method. No, You have to collaborate with all this because ultimately these APIs have to work effectively to gain and provide the business benefits to you. Now, to work on all of this, there are some integral changes that are happening throughout the API world, and that is depicted by this particular component. So we have these protocols that are working effectively, doing their respective task, so that we are able to have our work or our expected uh, API component delivering what it is supposed to do. Like if the API is intended to make my reservation and accept a payment for that reservation, then these protocols work in the background effectively to make sure that the reservation is meant to go to site A, which is your travel. For that travel, it is air travel. For that air travel, it is specifically between select point A and point B, which happens to be your point of leaving and your destination point. So everything is well set. The payment has to go to that ticketing website, which is your aircraft booking, nothing else. Beyond that, after that transaction is complete and you have made your reservation complete, comes the next API where you are looking at whether it is a taxi service that you want to avail, or whether the hotel is providing you, or you want to make your hotel reservation. Two APIs connected to reservation don't work parallelly, as you would have noticed. You cannot be in two places making a parallel payment, but these APIs can be executed separately by you or one other family members, where the work can be divide and rule, right? I say I will take care of the airline, you will say you take care of the hotel, but not on the same system, right? The earlier component of, let us say, multiple websites doing multiple activity may not be true till work A is complete. You cannot move on to work B. Now, having said all of this, we took a look at the overview. We took a look at some of the requisites that are necessary, because the shrink in terms of time and the devices that we use for the API design requisites. We also took care of the principles, where we said that the mnemonic to remember is uh, C, S cube, CB, and in the background we have all of these protocols. Now, it doesn't make any sense at this point of time to read out what these protocols are, but then you by virtue of your work, you would have well understood that REST protocol is the most desirable protocol that we have used to be working on. And then we have these webhooks, whereby from one system, when you call to another endpoint, these webhooks enable you to go and latch on to the destination endpoint. And then you also have another protocol which is very useful when your language in the background that you're using is XML, but that is slowly getting into oblivion. That was your SOAP protocol. Apart from this, there is something else called EDA, or event driven architecture. You have something called EDI, which is electronic data interchange, and you have the other players which are slowly making their way in. To give you a list, they are WebSockets, SSE, AMQP, MQTT, and GPRC. So the performance is growing up. You really require a high performance. So if you need very high and very good performance, which is at great speeds, then probably you need to use a high performance open source framework like GPRC. If you are going to have something within your office which will manage, then probably you will look at something called SSE, which is typically working within your own server space, right? So based on how you want to do, these are all what you call additional protocols that strengthen the execution of your API in the backend, which you are not going to see, but the architects will determine how they should be built in and what they should be used for effectiveness. Some of these that I mentioned about follow an open protocol standard, and if you are coming up with an open API standard, then you may think of using them. Other than that, you have to define and set these protocols within the available standards. So, like I'm saying, no, you have a client, you want to give a definite HTTP. It has to go to a URL, and there is a JSON communicating between the client and the server. Then you decide, okay, I will work on RESTful APIs. RESTful APIs occupy something like 69% of the overall API design space. People are comfortable working with that, and to a great extent, when you take up any course related to API documentation, you will find that the trainer prefers to work on Postman Azure protocol, where most of the command sets are entered within the scope of Postman, so that you are having a better feel and use. Right now comes, so far we have taken a look at what are the components that are necessary, where you have design requisites, you go through the design principles, and you've also taken a look at the design protocols. Having put these three in place, there is this important component that we tend to kind of underplay, but has a major role in most of our activities. And just like testing is an important component of SDLC, API testing is also equally important. So how does it work? If I look at the API testing, so if you look at the entire test automation pyramid, if I try to bring in an SDLC focus here and say that, okay, from requirements to release, you have some form of testing or going. In the API testing, you should look at the test pyramid as three layers. One, you have a unit layer testing, then you have a server layer testing, which is where the API's design principles that you built in through that mnemonic is actually tested, and then you have a UAI layer where you run a series of automated tests to ensure that they are picked up one after the other. Now, here is where AI can probably come into play, where the sequence of automated tests are run through AI. I really see the use of AI coming into play there, where the AI will take over, run through these automated tests, run through several layers of the AI UI across the devices that you plan to use, and test each one of them and say that your API testing is successful, yes or no. Right? Now, please understand, many companies allow you for some time, where once they have designed the testing, to ensure that you get familiarized, that's when, to play around with the code part of it, they provide you a sandbox for a limited amount of time. Some of these sandboxes are now getting priced, so they will charge you, but they will tell you that this is good enough for you to do at least up to 500 uses. So which means you as an individual can play around and have a maximum of 500 times that you can work within the scope of that sandbox. After that, they put a pricing model to it and make it pricey. Right now, what are the type of tests that must be run for any API to function successfully? You have to break it down into feature, and you have to put adequate blockers to ensure that if the testing fails, the blocker will take over and give you a hello, excuse me, beyond this it cannot proceed, please go and rework. So those are what I mean by those, what you would in SDLC components say, you have got your unit test cases, and corresponding to unit test cases you have unit test results. In the API world, they are called highlight blockers that should halt the testing and say, excuse me, you have what I see as a immediate fix that needs to be attended by you. Right? So these blockers are going to effectively make sure that beyond that certain point of time, unless you fix your design defect, it cannot proceed further. So what are the areas that it will impact? It impacts these four areas. There is something called functional testing, because any API is going to result in two components. One, it is a success, it is a failure. It is a yes, it is a no. So you need to look for positive and negative testing. Then you have something called a performance testing. Again, it is known as LS to the power of 4, because if you go by the consistency and other factors, here also you have to look at the overall load, the scaling, the security, and all aspects that are necessary. Then you have something called security testing, where it is called SPF. How secure is your API built in? Can anybody hack into that in terms of penetration? And because of hackers entering your system, is it creating an overload, or what I call your APIs fizzling out? So there is something called a first test also required. This SPF activity sometimes is also known as a pen test. Right? Now, last and most of the thing, when you do a testing, your APIs have to work on something called integrity and reliability. How far you can go on with your APIs. In the background, somebody should be constantly looking out to ensure that nobody is able to break into that API and spoil the flow. Because all of these in the real time are working round the clock. There cannot be any slip ups. We have to take effective care to ensure that our APIs meet these four components. So, if this is so important, then what are all the testing steps that I should look at? Where all should I look at? The first step will happen when I do the specification review, where I create the testing requirements. I look at the workflow of the application. I see what are all the various features that will be incorporated and how they function. I will look at how one API interacts with the other API, and also take a look at what I should document what are the problems that we are testing for, right? Then step two is I should establish this API environment, test environment, for which I will come up with a test specification document. Just picturize the actual testing flow cycle. You have something called test development documentation, or TDD. Then the moment TDD is in place, the next step is you analyze and see what are all the possible test cases that, or the test bed that you have to arrive at, which is done using the test specification document. Similarly, for API, you need to have an API test specification document where you have to elaborate on the functional scope, where the API will flow from step A to step B. And this normally is done by the DevOps engineers when it comes to their actual development. At the back end, there will also be the IT team and the architecture team, which will work on the configuration of the servers. This way, you will make sure that the function for which the API is determined goes through its functional scope, and it is properly meeting the requirement and in the right environment. Then comes the next component, where go back. If you have set your test bed, you would also have something called what you call a test run, or something called internal to yourself, where you have something called a system test checking. That is where I come to from the test framework development, right? In the same way, you will make a trial API and run it through a call. Before you go into the testing itself, between one person and the other person, internal to each other, you will see if the API is a pass or a fail, right? And make sure that it is operational and nothing is broken in between. Once it is set, what you can do is you can make use of the SOAP UI framework to have and see how it is going through operationally. And at the same time, just like you use testing tools for ensuring that your API works effectively, you can use something called JMeter and do a continuous testing process. Fine. Now, this will ensure that once you have done all this, then comes the test case development. What will happen is your test bed that you did in the test specification document has to actually be run, and for each test case, there has to be something called test results. This step is not to be skipped. This is a crucial step where we tend to compromise, just like in the documentation thing where we compromise on review. Similarly, people tend to compromise on this, that we have developed the test case, test specification. Okay, test case, we'll automatically run it here. It is already taken care of, but nobody goes in to actually check and see whether the background process that ran is actually meeting the desired result, yes or no, pass or fail. Unless you document it properly, this is also another area where we can step in and run it for on behalf of the development team if they are too busy. You can do the test case. The test case bed is made available. The test case results pass, fail, pass, fail. This way, what happens? Your knowledge about that API widens, and you can also look at an additional area where you can, because the product knowledge and the API knowledge is good, you can step in and do test case run also. So what you will do is you will group all of this and run them by the test category that they are supposed to perform. Last but not the least, the test execution results have to be reported. For each test result, there will be a value that is generated. So you input something, there has to be a process and there has to be a definite output. That output will have only two states. It's a pass state for the API or a fail state. So you have to see how this API runs, behaves in the system actually. Sometimes you also have to do, as part of testing, there is something called null testing, right? What if somebody enters the value called 0? Will the system take an input or will the system stop me from there? So system should be effective. It should not accept 0 as an input, right? So you should make sure that junk is also not fed into the system. Then you should also be able to see how that API is functioning effectively. There are no events or interpretations. After which, finally, the overall effect should be uh, authenticated and told to the users as an overall report stating that we ran so many APIs, it took the system so much of time to process, so many APIs were tested, all these APIs resulted in a pass, and the overall testing is a 99.5% successful. Zero point 0.5 can be actually determined when the load testing is happening, where we can simulate in the so and so environment and you indicate which is that environment. So finally, your very purpose of executing these APIs and making them into the marketplace is actually where you run through several API calls. Calls are made to the API and the processes run once again in with limited number of users. Then you extrapolate it to a greater audience and see if system is still able to take the load. That's how your scalability is also parallelly tested, right? Now, I would like to move ahead here and tell you in brief about what are all the software stages and what are all the API testing stages. What happens in the development phase is equivalent to call in our API testing world, it's called unit testing and integration testing. As soon as this development phase is done, there is something called a performance and load testing that has got to happen. On an ongoing mode, as the modules get developed, there has to be something called runtime error detection and security testing happening. Then the core testing will have to look for how these APIs interact with one another, which I know as interoperability, and how good they are when it passes the LS4, LS to the power of 4, or the first testing. Last but not the least, there is something called a user acceptance testing, which is known as validation testing in the API testing world. Why are all of these important? They are important because each one of them is very, very vital. For instance, in performance testing, you look at all the non-functional parameters are met in the test environment. Speed of the system, how much of entries it is able to take. Uh, if the traffic goes up, is it able to handle multiple heavy processes? Are these multiple processes running individually and they're not interfering with each other? And you also need to be available, look for once I pass these APIs into a production environment, am I getting the reliable result, right? So such is the kind of interaction that you have to do. Then there is something called runtime error detection that also your technology should be so good that at the back end you should be able to generate a very clear report which says that while in operation so many errors were detected. So you need what percentage of the API has met successfully. If it does not pass more than 75% of the requirement, then go back and address it, right? So security testing, like I mentioned in the LS4, it is also known as penetration testing or short for pen testing. Penetration testing is necessary when it comes to API because whatever you entered as in the browser window, when it goes to the endpoint, it needs to meet the satisfactory result. The flow of the API should not be lost anywhere in between. Last but not the least, by doing all of this, this is what happens. You are able to catch the defects early. You are able to give the feedback. By doing so, you are able to cut down cost and be at the same time efficient so that every test that is run results in a cost to the organization. You build in more security, you are able to integrate the APIs easily, and you are also able to ensure that the APIs work effectively because of the conventions that you put in very early, and they are not dependent on the either the device or the interface that is used in the device. Right? You have taken care of all the aspects. One device may be what you call iOS specific, another device may be Android specific, but you have taken care of all of them, and it is not what you call device specific, or it is not that it will work only in a specific browser. Whatever is there, it should work. Now, from having laid the base, here is where I would like to draw an industry example into play. Early in 2006, a little blue bird walked into our lives. It said tweet, okay? And all of us hurriedly went into an environment called Twitter, right? What did Twitter do? Twitter said you could make a tweet, express your thoughts, but in 140 words, right? Now, having said that, there were some limitations for Twitter at that particular point of time when it came into the marketplace in 2006. Early in 2012, here is an encapsulation or a pictorial representation of what Twitter did. Right? In early 2012, everything was they took a longer time for the write to work rather than the time for the read to work. That is because everything went into a mode called it was trying to push through an asynchronous path, which means that if somebody had to read your tweet, they had to do it under 5 seconds because multiple tweets were getting posted all throughout. But at that particular point of time, their architecture was not able to do that, because what was happening is in the process of pushing it out, these tweets were going and sitting across different areas. And most importantly, if you are an active person who was on Twitter, it would go and sit somewhere in your timeline over a period of time. Your timeline became too heavy, that the architecture in 2012 of Twitter was not good enough to handle this. So, if you look at the protocols, they use something called Redis. They also use something called early bird to do the searching part of it, because you would have tweeted on something, and when you went and looked up, there was in the background a process called it is trying to discover based on your tweets, search from within, filter out, and give you the specific tweet on what you discussed about. Today, that entire aspect, right, has changed. In 2022 and 2023, when Elon Musk decided to take Twitter into his control and brought it out, the first thing that happened was there was something called Elon Musk review of the Twitter architecture. They went back to the drawing board to study what is it that Twitter actually had as an issue and why it could not work. Today, the entire concept has changed. 150 million users at the same time are trying to push uh, tweets in such a mad frenzy that by the time somebody tries to respond to somebody who tweeted, there are other 300 million tweets that have already gone and come in from the users who are reading the same tweet. So if that is the case, going back to my earlier slide number 5, where I discussed on the various API protocols, my next slide is typically discussing how today, as a matter of X2, how they have branched out. So you could be coming from the web, you could be using your device, iPhone or Android, but in the front end, see what they have done. They have taken the timeline services and broken it up in tweet terms, Twitter architecture terms. I would call it federated. They have federated the whole thing and broken it up into various services. One is an onboarding, where you are new to X2 as it is called now. So you need an onboarded service. Your timeline gets defined, so you have a timeline scorer. Then based on how many followers you have and how well you're tweeting, then there is a ranking service. Right? So all of this have now gone federated. They have a proposed system to address this timeline services, take it, and like you take several ingredients, put it into a blender and make a smoothie, or let us say in the Indian context, early in the morning, 3 or 4 ingredients go to form the addition to your main breakfast, which is called chutney. Similarly, you have your federated of the services that is done. So what all have they done? In the backend, to store all the tweets that come in, something called Manhattan has been deployed. See the next one. To make sure that all the user profiles are stored properly, he has deployed something called Gizmo Duck. To ensure that your timeline displays a pictorial representation of what you want to see and how the database needs to organize all your tweets, he's got something called a social graph. Last but not the least, this is what caught my attention to a big deal. If you want all your tweet to be recognized by the hashtag or the tweet object so that you can reference it very easily, it's called Tweety Pie, similar to what we have at home where we say Sweetie Pie to address a kid or something like that. I don't know. That's exactly what they've addressed to find, and they prefer to call it, to recover the APIs, they've addressed it and called it Tweety Pie. Now, this is how thought process has gone in to make sure. And based on all of this, do I have more time? Are we good on the time aspect? Okay, I have another 11 minutes, but I must say that I should leave at least 10 minutes of this session for your benefit. So, having said that and started by saying what the session does or helps, here is an interesting stat I would leave you with. I would just request 3 minutes of your time to read all of this out. These are the top 20 uh, economic statistics that I have derived, which says that how well APIs have come into being and how much it is going to impact our lives. I had to take them in the order that they appeared. I have not done any sorting to this. So you will see a mix of 23, 24 interspersed with 2020 and 2021 too. So it is as it comes. There's nothing that I can do on this. So they have decided on what they should do. If you look at point number 5, it kind of validates whatever I said earlier. It said there are 46 million postman collections. Most of the API repositories internally for the developer to work on, it is GitHub, which is your configuration management tool, and that is how effective it is. Industries, open banking is one, healthcare is the second, and the third will be cloud automation will come in a big way. At the moment, retail is huge, where similar to Walmart, their vegetables and fruits division, which is the Walgreens, more than 600% of their customers don't come to the store. They prefer to do online. And that is a trend that we are currently seeing in the Indian economy too. Lack of time has ensured that there are players like Big Basket or Zepto or the Swiggies and the Zomatos making more money than you would take the trouble to step out of your house and walk to the nearest shop, right? So, on that note, uh, I would like to thank two people who I interacted with in my conference earlier on August 31st, Janira and Pradeep Srinivasan. If you're tuned in, a special thanks to both of you for allowing me to interact with Document 360 and making this possible. And to the entire team at Document 360, thanks a lot for your time.
Thank you, Gopal. The session was indeed insightful, and I'm sure the audience will agree with this. And thank you all for joining us tonight. Thank you for taking the time of your busy schedule. So we'll see you in another exciting session soon. Have a nice day ahead. Thank you, everyone. Thank you, Gopal.